the pH of a acidic buffer. We know that a buffer solution is a mixture of a weak acid and salt. Let's say Ha is the acid, a weak acid, which dissociates as H plus and the A negative, and this is the weak acid. Now the salt of the weak acid, let's say BA is the salt of the weak acid, and this salt, which is actually a strong electrolyte, dissociates completely into the B positive, the cation, and the anion A. This mixture of weak acid and salt is a buffer solution. Now let's write down the dissociation constant of the weak acid, which can be the concentration of the proton here, H positive ion, hydrogen ion, concentration into the concentration of anion over here, divided by the concentration of the acid. This is the dissociation constant of an acid. And over here I can rearrange this same equation. Let's say the concentration of the H plus ion will be equal to the dissociation constant into the concentration of the acid divided by the concentration of the anion. Now let's make here an approximation. An approximation of the concentration of anion. We have a mixture of a weak acid and the salt. You know that the salt is a weak electrolyte, as the salt is a strong electrolyte, and the acid here is a weak acid. So the number of the anions from the dissociation of an acid compared to the number of the anions from the salt, right, will be negligible, right? This concentration as compared to this concentration is negligible. So therefore I can say the concentration of an anion, if I write down the concentration of an anion here, will be almost equal to the concentration of a salt, and I assume here the concentration of the anion from the dissociation of a weak acid is very less. So therefore I can put this value over here, and we can rearrange the above equation, like we can say the concentration of the proton here will be equal to the dissociation constant of an acid into the concentration of the acid divided by the concentration of the salt here, right? And the pH of a solution is calculated from the H plus ion concentration. The pH equals negative log of the H plus ion concentration. So the pH of the solution will be equal to negative log of the concentration of the H plus ions, which is actually dissociation constant, into the concentration of an acid here. Ha is the acid concentration. Let me write down the acid concentration divided by the concentration of the salt here. And we can further rearrange the equation, like pH will be equal to negative log of the minus log of the dissociation constant K minus the log of the concentration of the acid divided by the salt concentration. So you can further rearrange it. pH will be equal to negative log of the K is actually pK value, right? We know that minus log of the K is pK, and negative log of concentration of acid by salt, I can write it plus log concentration of acid by salt. Now I can write the salt over acid. Now this equation is called the Henderson equation here, which helps you to determine the pH of a buffer solution. So you can find the pH of a buffer solution from the concentration of the salt and its acid. Now, similar to this equation, we can have a Henderson equation for the buffer, for the basic buffers. For the basic buffer, you can write down the Henderson equation. Now, similar to the equation for the acidic buffers, we can write down the Henderson equation for the basic buffers as the pOH will be equal to pKb plus log of the concentration of the salt divided by the concentration of a base. Hope you got it. Thanks for watching the video. Bye for now.